Hello, everyone. Welcome to Weekend AIP Open Seminar. I'm Hiromi Arai from AI Safety and Reliability Unit. We are going to start a seminar. But before that, here are some notices. First, reproduction is prohibited. Secondly, reproducing all of or any part of the content is prohibited without the author's permission. Third, this seminar will be recorded and the video will be available on the Weekend AIP website later. And if you have any question or comments, please scroll to the bottom of the page and click the Q&A tab, and you can put question or comments in the box. So let's start the first part. Firstly, I will give an overview of our unit. And our unit, AI Safety and Reliability Unit, is mainly working on novel ethical and safety challenges of AI technologies. And especially our research focuses on fairness, transparency, accountability, security, and privacy preservation in machine learning and data utilization by developing computational methods and conducting data analysis and interdisciplinary researches. And our unit currently consists of 2 members, and recently three visiting scientists joined our lab. And Nakasone-san and Kuziya-san, their background is philosophy, and Nakasone-san working on privacy and hate speeches, and Kuziya-san working on explainable AI and online harmful information. And visiting researcher, Dr. Tetsushi Ohki, is associate professor at Shizuoka University, and his research goal is establishing a security, privacy, usability, aware digital identity, and especially he is working on biometric security and privacy and usable biometrics. And another visiting scientist, Dr. Naoto Yanai, is assistant professor at Osaka University, and his research interests includes AI for security and security for AI, and network security and cryptography. And third, Dr. Yu Izumi is an associate professor at Nanzan University, and his research interests lie in the interdisciplinary areas between philosophy and linguistics. And he theoretically and empirically explores a variety of natural language expressions. And also he's working on the language of hatred and exclusion, especially in the context of contemporary Japan. And currently, we jointly study online hate speech. So in this talk, I first briefly introduce motivation of our research. Then I will talk background and our works on privacy and fairness and explanation and privacy policy analysis. Okay, so motivation of our research is to clarify the requirements for AIs from the society and how to achieve them. Recently, algorithms are used in many aspects of our life, including in decision-making systems. For example, medical diagnosis, scoring, hiring, and so on. So many of them are based on, personal data. So therefore, there are highly social demands on ethically aligned AI. There have been many guidelines and regulations. For example, IEEE ethically aligned design, or EU GDPR, and Japanese principles of human-centric AI society. Our research interest lies in these topics, and especially privacy, fairness, explanation, and safety. So let us begin with privacy. And recently, privacy concern arises since many AI applications collect, store, and use personal data. And personal data is any information relating to an identified or identifiable natural person, and often contains sensitive information, for example, racial or ethnic origin, political opinions, philosophical beliefs, genetic data, health rate data, and so on. More broadly, we sometimes treat private data, which means entities own private data, for example, organization or government's private data. And there are various definitions of privacy, but here we consider privacy as the ability of an entity to control its own data. For example, a certain person provides its health information to research institute, but he or she wants to keep it private and do not want to disclose the information to public. So let's consider privacy risks. And typical privacy risks are, for example, privacy data leakage by security breaches, such as unauthorized accesses to payment data, for example. And privacy risks in data sharing are privacy risks in data sharing can be considered. And for example, record re-identification from shared data and privacy leakage from, for example, models or statistical information. Also, profiling risks. For example, using consumer data to predict user-sensitive information, and scores of students declining informal job offers by using cookies and demographic information, or micro-targeting by Cambridge Analytica. To see a little more detail of the privacy risks, let me refer the re-identification by linking pointed out by Sweeney. And she demonstrated that re-identification by directly linking of shared attribute between two databases. And one is medical data without identifiers, and the another is voter list with identifiers. And these two records have three attributes in common, and linking on these shared attributes, some medical data can be re-identified. To examine privacy risks in data sharing, we assume advisory and define privacy that wants to be satisfied under this assumption. Then we develop methodologies that satisfies privacy definition or evaluate privacy risks. An example is attack on presumed sanitization. We are working on two kinds of privacy preserving techniques. And one is output privacy. This is methods to prevent inference attacks by evaluating privacy risks or obfuscated output. Another is cryptographic protocols for secure data transport and computations. And there are various privacy preserving techniques. But today, let's take a look at some of our previous works. We studied privacy risk quantification in publishing genetic testing results. This is a past work, but simple and good example of output privacy. And we consider genetic tests based on personal SNP genotypes, a kind of genetic information. And let X be the user SNP data and disease risk. And by applying this genetic information for genetic test function, we can obtain disease risks and consider the adversary to obtain disease risks and function information and infer values of original input X genetic data or private information related to X if the user published his or her disease risks. And under this assumption, there is the question is whether adversary can infer the user's SNP genotypes from his or her disease risks and other auxiliary informations. So let me explain some backgrounds of this problem. Disease risks are calculated from risk areas and parameters and odds of each risk area. Relative risk is the risk of having a certain disease relatively in a certain ethnic group and obtained by multiplying risk of all associated SNPs. And sometimes a certain kinds of a certain disease have many associated SNPs. So to calculate relativity, sometimes we have to multiply many risk factors. And for example, number of risk areas on a certain SNP is suppose the number of risk areas like this, and also these diseases with risk areas like this, then risk of disease can be calculated in this manner. And also, we also examine obfuscation of disease risks for privacy preservation. Then, to evaluate privacy risks, we consider reverse engineering attack. The adversary who executes this attack and adversary infers SNPs by calculating probability that SNP holds a certain value. And to calculate probabilities, we count up all possible SNPs that satisfies these risk values. Then we carried out experiments with real-world data sets collected by GBAS catalog and population data sets from HapMaps. This graph shows the attack success rate, and horizontal axis shows rounding parameters. So if this parameter is larger, rounding parameter becomes larger. So the output has small utilities. Then vertical axis shows the success rate of the inference, and the larger rate means the most of the disease risks are. The vertical axis shows the success rate of the inference, and if this rate is larger, most of the risk areas can be inferred correctly. So this graph shows the trade-off between utility and privacy preservation. And the lessons from this experiment is that there is a trade-off between privacy and utility. And if you want to publish, if you reveal accurate disease risks, most of the SNPs information can be inferred, so appropriate sanitization is important. Okay, and secondly, I introduced our work on cryptographic protocols for privacy preservation. And famous cryptographic protocols is secure computation by using homomorphic encryption. But here we show other interesting framework. So in this work, we consider the scenario that the system wants to detect the data provider who sends anomaly data without revealing normal users' identities. So consider data providers and anomaly analyzers, and data is collected through anonymous networks. So the collected data is anonymized, but anomaly analyzer can detect anomaly, only anomaly, and only anomaly can be re-identified. So challenges of the scenario is the contradiction between anonymization and detection, and the correspondence table for detection will make someone a big problem, and necessary to construct a generic privacy preserving framework independent of specific anomaly detection algorithms. And note that this is joint work with Takuya Hayashi in Country Digital College and Keita Emeras from NICT. And proposed model is like this. There are three kinds of entities: data providers, anomaly analyzers, and anomaly detectors. And anomaly analyzer can obtain whole data, but cannot detect any data provider. And anomaly detector can detect any data provider, but cannot obtain normal data. And we use two kinds of cryptographic tools. And one is public key encryption with non-interactive opening. And with this tool can prove the correctness of message ciphertext pair, but impossible to force a proof for a pair. So there are sender, receiver, and prover and verifiers, and verifier can verify the correctness of the message ciphertext pair using the proof pi. And the second tool is group signature with message-dependent openings. And this is a group signature scheme that for allowing a member of a group to anonymously sign a message on behalf of the group and propose to prevent the opener being a big burden. So there are signer and verifier and admitter and opener. And admitter's tag is required to open the signature. So overview of the proposed framework is like this. Each data provider encrypts his or her message with PKENO and signs to the PKENO ciphertext by GSMDO. And the anomaly analyzer decrypts the PKENO ciphertext, then detect anomalies using any anomaly detection algorithms. And also generates a tag as an admitter of GSMDO for anomaly data, and approve as a prover of PKENO for anomaly data. And the anomaly detector can verify the correctness of message ciphertext pair as a verifier of PKENO and detects the anomaly data provider using open functionality as an opener of GSMDO. So in the setup phases, anomaly detector generates keys as opener of GSMDO and generates key for PKE, and anomaly analyzer generates key as admitter of GSMDO and genetic key of PKENO. And in the analyzed and identified case, data provider increases data increase message and sign, and anomaly analyzer analyze data by decrypting the message and also make proof and tags. And anomaly detector can identify anomalies and sends anomaly analyzer sends a set of encrypted set of parameters of the anomaly data to anomaly detectors, and anomaly detector can identify who is the sender of the anomaly data from these parameters. Then evaluation on the proposed framework is shown in this table. And so our contribution of this work is on the as follows. On the proposed model, assume that entities are honest but curious and no collusion between the anomaly analyzers and anomaly detectors. And we proposed a secure and generic framework for anomaly detection, and overhead is around dozens milliseconds per data records. So very computationally efficient. Okay, so let's move on to the next research topic, fairness and explanation. There has been concerns about AI bias or discrimination by AI. For example, Cathy O'Neill, who is opinion leader of algorithmic discrimination, warned in her book, Weapons of Mass Destruction, that big data algorithms reinforce pre-existing inequalities. And also, there are many historical cases. Some examples are as follows. Gender bias in Amazon's hiring algorithms, and discrimination in online as jewelry, and inequality in face recognition systems, and so on. So let's consider fairness in machine learning. And briefly, fairness in machine learning means the treatment of individuals are independent of sensitive information, such as gender, racial, national origins, in AI applications, especially hiring or scoring, and so on. And various definitions and properties, there are various definitions and properties. For example, Professor Narayanan claims that there are 21 fairness definitions and their politics. And there are many properties. For example, consider fairness by group or individual, or disparate treatment, or disparate impacts, and so on. And to approach these problems, there are many approaches. For example, fairness evaluation or fairness aware machine learning, and so on. And also, recently, explanation for AI decisions, there are many studies on these topics, and motivation of this research is demands of explanation of algorithm decision making, and sometimes machine learning models are huge and complex and hard to understand. And so research on XAI is becoming more active, and notions that are intuitive but difficult. So there are many debates what is XAI and what is requirement in the community. And here we refer the interpretability by Doshivelis and Kim, and they claim that the interpretability is an ability to explain or to provide the meanings in understandable terms to human. And interpretability can be obtained by building a model interpretable by design or through black box explanation. Then, what is black box explanation? And so there has been many methods proposed for black box explanation. For example, explanation complex models in a simple manner, or explain outcome and explain why this outcome is provided. Then, among these research topics, we found the risk of rationalization in black box explanation. We define fair washing as malicious decision makers can disclose a false explanation to rationalize their unfair decisions. And this study it is impossible to systematically generate false explanation and raise awareness of the risk of fair washing. This is a joint work with Ivoji and Sebastian Jams and Satoshi Hara and Olivier Blondel and Alan Tams. So let me show the scenario. Consider unfair AI services such as a scoring service. And actually it is unfair AI and reject applicants based on their gender. And honest explanation in this case is your own application is rejected because your gender is blah, blah, blah. But consider dishonest explanation is your loan application is rejected because of your income is low. To show the risk of fair washing, we propose laundry ML. This is the method to systematically generate false explanations. And idea of this method is generates many explanations and pick one that is useful for fair washing. To generate many explanations, use model enumeration methods and many enumerate explanation models. And in pick one process, we use some fairness metrics such as demographic parity and pick an explanation most helpful to the model with demographic parity less than thresholds. And as an explanation, we consider black box explanation and especially model explanation, and define model explanation as follows. Given a black box model B and a set of instances X, find an explanation belonging to a human interpretable domain through an interpretable global predictor derived from the black box and instances X using some processes. And to evaluate explanation, we use fidelity and unfairness. As a fairness metrics, we choose demographic parity, and y hat is the prediction value, and x is positive outcome, and s is sensitive information. So, and s equal 1 means belongs to a probabilistic group, and s equals 0 means it belongs to complements group. And so fairness is defined like this. So probabilities of having a positive outcome is the same between two groups. And then we define unfairness is the absolute values of the difference of these two values. And we also consider fidelity that given the base model B and the surrogate model for explanation is C, and a test set X test, and the fidelity of C with respect to B is defined in this manner. So, and laundry ML takes as inputs the set of antecedents. And laundry ML building blocks. As a building blocks, we use coils, which builds predictive models with full lists and model enumeration methods. And the main characteristics of this method is to explore the search space of full list using modified version of coils. And objective function is the sum of the misclassification value and unfairness values and model size. And enumerate list models using the constraint coils. Then we did experiments, and we use dataset, adult income dataset, and use gender as sensitive attribute. And we choose random forests as a black box classifier and evaluate explanation by fairness and fidelity. And here is the fidelity and fairness of the enumerated models. And there is a fairness fidelity trade-off, and but we can find models with high fidelity and low unfairness. And choosing this model, we can rationalize a model, a black box models. And here is a future importance by PRML on gender. And the future importance has dropped from, this is the original black box model, and the future importance of gender is high, but in a false explanation, the future importance of gender is low. And this is the obtained false explanation. And the summary of this part is we raise the awareness of the risk of fair washing, and with laundry ML, we can systematically generate false explanations. And lastly, I will explain the explanation of data practice. Currently, notice and consent is required to collect and use personal data, and generally privacy policy is used to inform users about how personal data is collected, processed, and used. And there are many points to be improved. For example, use of vague and ambiguous language, and complexity, and its readability. And recently we are working on this topic, and our first step is a study of information extraction in Japanese privacy policies based on contextual integrity. And we use the theory of contextual integrity, and in this theory, privacy is defined as the appropriateness of information flows. And this theory offers a template for describing information flows using 5 parameter tuples: sender, recipient, transmission principles, attribute, and subject. And here, transmission principle means descriptions of how information may be used or correspond, and attribute is the description of information type. And here's the example of the annotation, and excuse me that this example is written in Japanese, but to this study, we developed Japanese annotation guidelines based on shared annotation framework, and annotated 3 excerpts of privacy policies by 5 annotators. And discussion from the results from this annotation is some of them, there are some ambiguous expressions, and some of them are not harmful, such as omissions. But we found some incomplete information flows due to obfuscation of entities or transmission principles. And so such ambiguous expressions should be improved, and information flows should be written in complete manners. And also we observed several annotation disagreement. And from this observation, we consider that clarification parameter definition may improve description and annotations. So summary of this talk. Our research interested in novel ethical and safety challenges of AI technologies, and we have been working on privacy preserving techniques and ethical aspects of AI and privacy policy analysis. And we also have several ongoing works of new research topics. And lastly, we are hiring and we welcome collaborative researches. So this is the end of this talk. And so let's move on to Q&A session. So if you have any questions or comments, please scroll to the bottom of the page and click the Q&A tab. Any questions or comments? Okay, so question from Christoph Sen. And are you also pursuing research in more classical safety? And for example, autonomous system like cars. Well, our research target is safety in information systems. So, and especially in AI or machine learning. So, unfortunately, this is not our focus. Any other question or comments? Okay, question from Chibin. And can you explain a little bit more about the explanation of black box model? Why the model internal should be considered as black box? Okay, we consider, for example, in the case of the fair washing demonstrated in this talk, we consider huge random forest as a black box because it is not interpretable by humans. But I think there are many ways to explain such huge and complex models. So using surrogate model is one approach, but I think we can choose another approaches. Is this okay for your question? Okay, so from Miyake-san, how do you evaluate the reliability of AI? Okay, this is a big question. And I think there are various discussions of the definition of reliability and also what reliability means. And in this talk, I assume, for example, fairness or transparency or explainability is a part of reliability, but there are many opinions. So if you have any opinions, please let me know. Thank you. And okay, and question from Thomas. Thanks. And how about safety in brain-human machine interaction? Do you consider such a hot topics, AI versus human? Very interesting question. Yeah, and yeah, very hot topic, I think. And I'm not a specialist in brain research, so this is just a naive comment, but I think this is very very interesting. So let's have a discussion on this topic later. Okay. And from Miyake-san again, do you have an aspects of evaluation? Sorry, could you give me question more detailed? I want to know what aspects of evaluation means. So could you provide what is aspects of what evaluation means? Okay, and from Anim, the fairness definition is too simplistic because combined data descriptors can infer the information probabilistically. Yeah, but in this talk, we considered fairness as fairness in the output of the outcomes of the decision makings. But I think inference attack is a kind of privacy problem. So if my understanding is not correct, could you explain a little bit more about your question? Okay, and question from Yanaka-san. Thanks. And is there any de facto way to ensure the explanation given by ML model is not washed? Actually, we examined in this problem, and I think it is a little bit difficult if we because in most cases we can access only limited data, but false explanation is quite unethical issue. So I think we need to consider another way to, for example, audit explanations. For example, we have auditor for automatic decision making, and yeah, not only by algorithms, but for example, making penalty. Okay. Thanks again, Miyake-san. And his question is, for example, IRC defines the 7 properties: domain analysis, case coverage, data distribution, accuracy, robustness, dependability, and stability. And okay, thanks for the comments. Okay, so I will answer your question later by chat. Thanks for the comments. Okay, so sorry for being late. So I'm going to move to the next section. Thanks for listening. 開始が遅くなって申し訳ございません。それでは2番目のパート、日本語、ちょっとまだ日本語でしか発表していない内容ですので、日本語での発表とさせていただきます。ソーシャルメディアにおけるヘイトスピーチ検出に向けた、日本語データセット構築の試案と題しまして、発表いたします。これは、南山大学に所属されて、また私のユニットの客員でもある泉先生と、朱さん、中曽根さん、谷中さんとの共同研究になります。この研究の背景としましては、ソーシャルメディアなどのネット上における攻撃的、暴力的表現への懸念があります。で特に社会的弱者を標的とした、すみません、いわゆるヘイトスピーチ を扱います。また、コロナ禍においては、特に排外主義に対する懸念があります。で、ヘイトスピーチ検出に向けた取り組みとしては、データセットの作成、分析などの取り組みがこれまでになされてきています。でヘイトスピーチとは、性別や人種や宗教などの属性に基づいて個人や集団を貶め、暴力や差別を扇動するような言説と、考えます。で差別の一形態で標的は社会的弱者、マイノリティになります。で単に乱暴な言葉遣いが含まれているですとか、集団について語っているとかではないということをご留意ください。でヘイトスピーチというのは、大まかにはこのような定義がなされますが、統一的定義が不在であるという問題があります。社会学、法哲学などでも、多様な定義がございます。でまた、各国の規制法もそれぞれです。で類似ですが、悪質な、コンテンツというものもありまして、ネットいじめですとか、乱暴な表現、一般などがあります。で関連研究としましては、さまざまな言語でのデータセットが研究されていたり、データ収集先がさまざまであったり、また、ヘイトスピーチの分類方法としては、人種差別的、もしくは性差別的であったりですとか、憎悪的や侮辱的など、さまざまな分類方法があります。また、南アジアでの女性で私的結婚高さなどの地域性や、知識的なものを、例えばコロナ禍における反アジアヘイトスピーチなどが、研究されています。ヘイトスピーチのデータセット構築において考慮すべきことと失礼しました。しましては、アノテーターに概念を判断させる場合の不一致というものがあります。ヘイトスピーチの見解の不一致や厳密な定義の難しさや、これまでにも性差別的という概念をアノテーターに判断させるようなことが難しいといったことが指摘されています。また、アノテーターがヘイトスピーチに対して一定の理解があることが前提となっているような場合もございます。で人種差別的バイアスの懸念といたしましては、黒人英語をより攻撃的なものと分類するというような指摘もあります。このようなことから攻撃対象、攻撃内容、攻撃の程度などラベルの詳細化の試みがなされていまして、本研究もこれにの中に載ったものになります。研究目的といたしましては、日本国内における排外主義的なヘイトスピーチに焦点を当てて、日本語のデータセットの作成に向けて、トライアルをいたしました。で日本独自の歴史、地域性を踏まえ、また人文科学におけるヘイトスピーチに関する理論的知見に依拠したアノテーションガイドラインを作成すること、またコロナ禍を考慮することを目的としました。また、アノテーターの主観的な判断に委ねる要素を極力減らすため、ラベルの精緻化やガイドラインの詳細化を試みました。以上の観点で研究を進めています。でデータセット構築の狙いとしては、日本語でデータを作成すること、概念の不一致や、判断の不可の問題を改善することが挙げられます。で概要としては、検索語を用いてヘイトスピーチの候補となる日本語のツイートを収集する。また、ガイドライン設計としましては、概念を使用せず、攻撃内容と攻撃対象について細分化して分類をする。また、アノテーションはクラウドソーシングにより、各ツイートに3名の作業者をつけるということを行いました。日本語のツイート収集は、Twitter ライブサーチ API を利用して、排外主義的なツイートの収集を目的として12件の検索語を用いて収集を行いました。でまた、データ収集の方法や期間としては、検索語とコロナを検索、または除外検索し、検索しました。 で、2020年の12月初頭の9日間で1日100件を上限に収集しました。で、そこからさらにランダムに選択し、コロナを含むものを230件、コロナを含まないものを270件をアノテーション対象としました。ラベルの概要としては、攻撃対象、攻撃内容について、それぞれ4つ、5つの定義を表に示すように与えました。で、A と B からそれぞれ1つ、もしくは被害と C を選択するというようなルールでラベルを作業者につけてもらいました。で特にこの研究の特徴としましては、攻撃内容についてのラベル B において、日本のいわゆるヘイトスピーチ解消法施行に伴う啓発活動において用いられたヘイトスピーチの例示及び川崎市のヘイトスピーチ禁止条例解釈指針を参考に作成した項目を入れてあります。で、ラベルの内容としては、攻撃対象として、容易に変更できない人の属性に基づくグループや、それに当てはまらない何らかのグループ、もしくは個人、もしくは対象がはっきりしないもの。攻撃内容にしましては、先ほど言った日本特徴的なものとして、B1、コミュニティや地域からの排除を告知、先導するもの。B2、生命を脅かす精神的、身体的な危害を加える、名誉を傷つけるなどのことを告知、先導するもの。もしくは口汚く罵りや侮辱、不確かな根拠に用いた処方を言いふらす、拡散させる、それにもどれにも当てはまらないといった項目を作成し、ラベルを作りました。例としては、例えば、政権花子は今すぐ辞任すべきであるというような発言に対しては、政権花子という政治家個人に向けられているので、A3 のラベルがつき、これだけならば攻撃的とは言えないということで、B5 のラベルがつくといったようなところです。で、アノテーションは3名にクラウドソーシングプラットフォームのランサーズを通じて依頼しまして、テストを行って実際に全問正解するまで繰り返し実施していただいて、ガイドラインの対する理解を深めていただいた後に、各ツイートをそれぞれ3名のうちアノテーションし、多数決によって2名以上一致したものをラベルとして取りました。でデータセットの概要としましては、検索後とコロナを含むツイート230件、検索後を含みコロナを含まないツイート270件で、個人的ラベルを得たデータは、コロナを含むものが 56.5%、コロナを含まないものが 46.3% と、どちらもおおよそ半数となっていました。で、本研究で無害と判定される B5 のラベルを得たデータは、半数程度とかなり多い割合になっていました。また、ラベルがつかなかったケースというのも存在しました。で、考察としましては、差別語を含むが無害な事例として、カウンタースピーチに当たる事例や、差別語が含まれているだけであるが、特に誰かを貶める目的のない事例というものが観測されました。また、コロナ含むものと含まないものの比較としましては、ヘイトスピーチに該当するものはいずれも低周順でありましたが、B4 と A1 の組み合わせは、カルドで 30%、ナルドで 23% と、コロナの流行にかこつけた暴言は、であることから、コロナの暴言にかこつけた暴言は、デマやフェイクニュースの形を取りがちであるかもしれないというような、ことが考えられます。また、アノテーションが揺れた事例がございました。これは、ラベルがつかなかったツイートは判断の難しい事例があるというふうに考察されました。また、他国の権や政党に言及したものなどは個人差があったケースがありました。この、ヘイトスピーチのところまとめとしましては、日本語の排外主義的なヘイトスピーチ候補ツイートに対し、精緻化したガイドラインによるアノテーションを実施しました。で、ガイドラインの精緻化により判断のよりはある程度抑えられたと考察されました。また、ヘイトスピーチの傾向について仮説が得られました。また、アノテーションや個人差について考察を実施しました。で、今後の課題としては、データセットの大規模化や、ガイドライン改良によるアノテーションによる個人差の改善ですとか、 ノイズや差別語を含むが非攻撃的な発言というのが識別できるかといった問いや、人文社会学の観点では、今のガイドラインでは区別できないものに対して判定するための理論的研究が、可能ではないかと考えられます。以上になります。質問、コメントとお願いいたします。上島さんから質問いただいております。版に合うと使われる用語がどんどん変わったりするので、本質的にアノテーションで対応できる問題でしょうか。コメントありがとうございます。おっしゃる通りだと思います。差別語が今回はかなり昔からずっと使われているものを使ったんですが、こういったケースを非常によく考えられると思いますので、この点についても考察したいと思います。ありがとうございます。詐欺様からのご質問で、データセットの公開は予定していますでしょうか。ちょっとまだ公開はしておりません。またツイッターのデータを使っていることから、ID の公開できるのは ID で、そこからたどっていただくという形に、なると思います。もしご興味があれば、もう少し詳しくお教えいたいということがあれば、問い合わせいただければと思います。三宅様から、音声でという、ことなのですが、すみません、これって、喋っていただくことっていうのは可能でしょうか。
私は酸素研でちょっと研究をやってるんですけど、
はい、
機械学習必須マネジメントガイドラインっていうのがあって、
はい、
それで7つぐらい特性を挙げて考えているんですね。で、なんかそういったことを考えてるのかなって思ったんで質問しました。以上です。
ちょっと不勉強ですみません。ちょっとまた改めてディスカッションさせていただければと思います。ありがとう
わかりました。はい。どうも失礼しました。
すみません。ちょっと声の方が聞き取りづらかったようで、大変失礼いたしました。これで全部回答しましたかね。これはコメントですかね。restricting uses of machines to explainable ones is not socially feasible policy。そうですね。そのように思います。もし追加の質問などあれば、ちょっと書いていただければと思います。ありがとうございます。他に質問などございますでしょうか。では、すべての質問に、回答できたと思いますので、これで、終わりにしたいと思います。貴重なお時間いただきましてありがとうございました。引き続きセミナーがこのようにございますので、ぜひ皆様、ふるってご参加いただけますと幸いです。はい、では、セミナー、私の分、本日分、こちらで終了したいと思います。皆様ご参加いただいてありがとうございました。So, this is the end of this talk. So, thanks for participating in this seminar.